Roger, well, first thing he did was relate superpositions to general relativity. I mean, he addressed the question that nobody else was asking, and nobody else still is asking: how the heck can things be in multiple places at the same time?
No, the biggest roadblock to anybody understanding quantum mechanics.
Exactly. And then you can ask, well, why don't we see those? First, you got to accept them as real. Well, he did a very clever thing that I think is still underappreciated to this day. He brought in general relativity, Einstein's general relativity, which showed that mass is equivalent to or causes space-time curvature. In 1919, Arthur Eddington did the experiment. He went to a mountaintop during an eclipse and saw these stars behind the sun, which had to be bent by the sun. He knew where they were and where they were supposed to be.
Gravitational lensing is the term I believe that they use now.
Exactly. Thank you. And he won his own Nobel Prize for gravitational lensing, which Einstein had predicted. Einstein already had his. Anyway, Roger Penrose applied that to tiny particles, and nobody else had ever done that, and still has, as far as I know. He said a tiny particle will have a tiny curvature, and if it's over here, it'll have a tiny curvature here. So a superposition of particle here and here is actually separated curvatures in space-time, which he portrayed as two-dimensional sheets in a very clever way. And so, therefore, a superposition was actually a separation in space-time geometry. But Roger instead said, no, the separations are unstable, and after a time, T will collapse to one or the other, and that is kind of like a little quantum computation where you have multiple possibilities and you pick one. And in quantum computers, the choices are, well, you run the quantum algorithm, but then collapse occurs, there's some randomness that comes in. But Roger said, well, this type of collapse occurs. It's not random, but it's influenced by Platonic values embedded in space-time. So within the space-time geometry in which this is happening are some kind of Platonic values. And he was a little bit vague about that. You could take it as good, evil, or you could take it as divine will, as judgment, as truth, wisdom. It kind of depends. But it's something that influences the choice of collapse that's neither random nor algorithmic. A little bit of spirituality coming in, if you assume that the Platonic values are something that stand for good and benefit and so forth.
And I think you're also touching on the concept of free will.
Exactly.